So the last type of symmetry that we're going to talk about is something called rotational symmetry. Okay, and so a figure has rotational symmetry if it can be rotated about a point by an angle greater than 0 degrees and less than 360 degrees. Okay, so that the image coincides with the pre-image. Right, so this part is kind of the same as before. Right, so last time when we were talking about line symmetry and we had this pre-image, we found this line of reflection so that if we reflected it across that line, our image would coincide with our pre-image. Okay? Well, obviously now, instead of talking about reflections, we talk about rotations. Okay? And so there's a couple important things that we want to be able to remember with rotational symmetry. So the angle of rotational symmetry is the smallest angle through which a figure can be rotated to coincide with itself. Okay? This is something that's important. You should definitely highlight this in your notes. Okay? So again, this is going to be, why is it not giving me my highlighter? There we go. Is going to be the smallest angle through which a figure can be rotated to coincide with itself. Okay? So again, take a look at the square that we have here. Okay? So if you look at the square, okay, if you rotate it 90 degrees, okay, or if you want to think of it as a quarter turn, okay, the image would coincide with itself or with its pre-image. All right, and so you notice that if you shift it another 90 degrees, again, it coincides with its original figure. And another 90 degrees, and it's still the same as the original pre-image. Okay, now this is getting at this. Okay, the number of times the figure coincides with itself as it rotates through 360 degrees is called the order of rotational symmetry. Okay, so we look at this word order, and that's the one that we're going to have to be familiar with. Okay, so in this particular example, we would say that the angle of rotational symmetry, so I'd say angle of rotational symmetry is 90 degrees, right? So that's the smallest angle where we have to rotate our figure to actually get a copy of itself. Okay, the order, pretty simple. The order here is 4, right? So we have 4 total rotations until we're back to our original image, not going any higher than 360 degrees. Okay, so what we kind of have to understand here, and it's a nice way to check your answers, is these two numbers, the product of those two numbers always has to be equal to 360. Okay, it's kind of a nice rule of thumb to just check and make sure that you're doing those appropriately. Okay, so let's look at a couple other examples here. Okay, so for part A, you're given kind of this weird little thing going on. Not exactly sure what that is. So let's take a look at part A. So part A, we're just going to look at, well, kind of some weird stuff going on there. If we rotated that from somewhere in the center, I don't actually think we'd get a copy of itself. And so I'm just going to say no on this one, and we'll just say no. Let's say image would not match the pre-image. Okay, let's look at part B here. Okay, so part B, you have something that maybe looks like a flag that's in the wind. You know, let's think about this. Okay, if I were to rotate this 90 degrees, this might be what it kind of looks like. Okay, so that definitely would not be a copy of itself. Okay, but if you actually rotated that again, you know, another 90 degrees, you get something that looks like this. Now these lines would be parallel on the outside, and you get this again. Okay, so it looks like you have to do two 90-degree rotations there to actually make that happen. Therefore, if we did a 180-degree rotation, that would be the angle of rotation. Okay, so we'll say, for this one, I'll just say angle is going to be so it's not 90 degrees, it's 180 degrees. So angle is 180 degrees, and our order would be 2. right? You could do 2 total 180-degree rotations until you're back to originally where you were without going over 360 degrees. Okay, and then one final one on here. Oh. Okay, and so my apologies about that. And so one final one here, if we thought about this as the center of rotation here, and we rotated it, it looks like 90 degrees. You can kind of notice all of these right angles in here too. Okay, and there are 4 of them. If we rotated that 90 degrees, you would see that the image would match the pre-image. So on this one, our angle of rotation would be 90 degrees. Okay, and our order here would be 4. Okay, and again, we can always check the product of those numbers and make sure that they add up to 360 degrees. Okay, and finally, there's just a couple more. Maybe it might be a good idea to check out these examples and use the video to check your answers. Okay, but on this particular one, it looks like if this were our center of rotation here, okay, and this were our center of the figure, and we rotated it about the center, it looks like we would get a copy of it after, you know, it's again greater than, it looks like it's greater than 90 degrees but less than 180 degrees. Okay, if we notice these 3 vertices here, it looks like our order would actually be 3. It looks like you do 3 little turns there before it actually rotates onto itself. So I'm going to start this one differently. I'm going to say my order is 3. Okay, and I know that, you know, the product of my order and my angle has to be 360 degrees, so that must mean that my angle here would be 120 degrees. Okay, looking at part B, yeah, on this one, you could maybe say your center is going to be about right here. Okay, if you were to rotate this 90 degrees, you'd get something that looks like this, right? So that's not going to help us out too much here. All right, and so now we want to say, well, what if I rotated it another 90 degrees? Okay, if you did another 90 degrees, you get something that looks like this. Okay, which looks like a replica of what you originally had. Okay, and so we would say that, well, it looks like that is 90 degrees. Okay, or two 90-degree rotations, so 180 degrees. So our angle would be 180 degrees. Okay, and our order would have to be 2. Okay, and so again, pretty simple stuff. And then finally with this last one, it does not look like this particular triangle is going to have rotational symmetry. So we would say no, this particular triangle has no rotational symmetry.